Okay, what if I told you that the deepest laws of the universe aren't really about what will happen, but about what could happen? We're about to dive into a radical new way of thinking about physics, one that completely flips the script, moving the focus from what is to what could be. Welcome to the world of the possible. So let's kick things off with this fantastic analogy from one of the pioneers of this new theory, Chiara Marletto. Think about it. Why is a lifeboat on a ship? It's not there because of a shipwreck that's already happened. It's there because a shipwreck could happen. The mere possibility of that event explains why the lifeboat exists. That idea is called a counterfactual, and it's a simple thought that honestly changes everything. So why do we even need a whole new approach? I mean, traditional physics has been unbelievably successful, right? But it turns out it has a massive blind spot. It's amazing at predicting the future if you know exactly what's happening right now, but it's not so great at explaining why things are the way they are in the first place. For centuries, ever since Galileo and Newton, the game has been pretty much the same. You give me the laws of motion, like gravity, and the initial conditions, basically the starting position of everything, and boom, I can tell you the entire future of that system. This idea led to this famous thought experiment called Laplace's demon. It's this imaginary, all-knowing being that, if it knew the exact state of every single particle in the universe, could see the entire past and the entire future. It's a pretty powerful image, but it's hiding a pretty deep problem. And here's the million-dollar question. The whole system depends on those initial conditions, but traditional physics has zero explanation for where they come from. Why were the conditions at the Big Bang just so? They kind of feel arbitrary, like they were just tacked on to make the math work out. And for a physicist, that is a huge, unsatisfying hole in our understanding. And this is exactly where this new framework, developed by the physicists David Deutsch and Chiara Marletto, storms onto the scene. It's called Constructor theory, and it's not just a tweak, it's a complete change in perspective designed to solve these exact problems. The shift in thinking here is, well, it's profound. Instead of focusing on what will happen based on where things start, constructor theory asks a totally different question. What transformations are possible and what transformations are impossible, and why? The fundamental laws of the universe become principles about what can and cannot be done. Now, to build this new way of thinking, we just need a few really simple concepts. First up is a task. A task is just any physical change you can think of. It could be something as simple as changing the face of a die from showing a 3 to showing a 4. That specific transformation, that's a task. Next, you've got the substrate. That's simply the physical thing that's being changed. So in our little example, the die itself, the object that's being transformed, that's the substrate. Pretty straightforward, right? And now for the star of the show, the constructor. A constructor is anything that can perform that task over and over again without being used up. This is key. It has to be able to cause that same change reliably, again and again. A car factory is just a perfect real-world example of a constructor. Its task? To transform raw materials into a finished car. But crucially, at the end of the day, the factory is still standing, ready to build another car tomorrow. It hasn't been consumed by the task it performed. Okay, so we've got our new toolkit. Tasks, substrates, and constructors. But how does this new way of thinking, this framework of what's possible and impossible, actually give us real, powerful explanations for the world we see all around us? Check out this pendulum. Why is a physicist totally unafraid to stand in its path? It's not because they did some complex calculation of its trajectory. It's because they know a fundamental law, the conservation of energy. It is impossible for that pendulum to just magically gain energy and swing higher. So, you see, a statement about what cannot happen gives us a rock-solid prediction about what will happen. And what this reveals is something incredibly deep. Some of our most powerful laws of physics are actually just statements about impossibility. The laws of thermodynamics, for example, they don't just describe things, they actively forbid things, like building a perpetual motion machine. These rules about what you can't do, these counterfactuals, are what give the laws their true explanatory punch. Now, this new way of thinking has some truly massive implications. And one of the biggest is that it might finally let us give a precise physical definition to a concept we use every single day but have always struggled to pin down: information. So what is information really? I mean, not as some abstract idea in math, but as a physical thing, something that's actually governed by the laws of physics. Well, constructor theory defines information based on two of these could-be properties. A physical system is called an information medium if two specific tasks are possible. First, you have to be able to reliably flip its states, like turning a 0 into a 1. And second, you have to be able to reliably copy its states. If you can do both of those tasks, congratulations, that system can carry information. It's not about the state it's in now, but the states it could be put into. Okay, now for the really wild part. Let's take this powerful new lens and point it directly at the most mysterious, most baffling part of modern physics, the quantum world.
This leads to this amazing concept called superinformation. The theory suggests that quantum information isn't some bizarre, exotic new thing. Nope. It's just regular information that happens to exist on a physical medium where certain tasks, like making a perfect copy of it, are fundamentally impossible. All of that quantum weirdness, it suggests, might just be a consequence of these built-in prohibitions.
And this one single idea, that it's just information on a medium where some tasks are forbidden, could be the unified root cause for so many quantum mysteries. The famous no-cloning theorem, the Heisenberg uncertainty principle, why just measuring a quantum system changes it, even something as mind-bending as entanglement. They might all just be different sides of the same coin, all consequences of these fundamental impossibilities.
And, this isn't just some philosophical hand-waving. It's a formal, mathematically rigorous theory that's being actively worked on by physicists right now. They're trying to build an entirely new foundation for science, starting not with particles and forces, but with these fundamental principles of what's possible. So where does this all lead? If this way of thinking is on the right track, what's the ultimate goal? What's the next frontier? The ambitions here are absolutely revolutionary. The goal is a unified theory that could express exact laws for things like thermodynamics and maybe, just maybe, even create a physics of life itself. It could let us define knowledge in purely physical terms as a special kind of resilient, self-copying information. And of course, the ultimate prize? A new foundation that might finally help us unite general relativity and quantum mechanics. So this leaves us with this incredible, mind-bending question. If things like life and information are governed by these physical laws of possibility, could the same be true for knowledge and even for creativity? Are there fundamental laws out there just waiting for us to discover them? It really opens up a whole new world to explore.